Hello. Yeah, hi folks. Good evening. Hello everyone. Good evening. Um. So yeah. Hope.
Yeah, hi folks, good evening.
Yeah. So hope the bootcamp has been informative to you all. Right. We have covered several topics in the bootcamp. Um. And hope you all could follow it, and also you know you could follow it as well as enjoy it as also. So yeah, this is the final session. We would briefly just go through whatever. I mean, we'll just briefly do a recap of whatever has been covered in the previous session and introduce some new topics. I mean, some machine learning topics we shall introduce, and then we'll quickly do a hands-on project. Right. We'll quickly do a hands-on project through which you'll also get some you know taste of machine learning. Um, I'll I hope you guys have the access to the collab notebook, right? Yeah. So I hope you guys have access to the collab notebook. In case you don't, please. I mean, I think the collab notebook link was shared with everyone, right? So in case you don't, please check out with the organizers. And yeah, this is the final day. Yeah, today also the procedures have the procedure has been same that please remember to fill your attendance, like please remember to fill your attendance, and there has please also do pay attention to this internship program by Corizo in case you like feel interested. Please put your names, right. So now we'll, without wasting any more time, we'll quickly start with the session. So I'll share my screen and start it. So yesterday we saw how we can do data analysis using pandas. We all when we did some small scale data analysis. We saw how we can read a yeah, we saw how we can read a table. We also saw how we can create a table for ourselves, and you know um, we also saw. I mean, we created a random table for ourselves and tried to generate some insights out of it. We still could manage to. I mean, even though the table was random, we still could manage to get some insights out of it. So yeah, lucky yes, but yeah, so we saw how we can use pandas to manipulate data sets, analyze them, leverage them to generate insights. We also saw how we can use matplotlib, right. We also saw how we can use the matplotlib, the Python's default the Python's most used library for plotting data, right. Uh, so we did make some plots. We explored all the different plots, which I mean, not all, the major plots which Matplotlib provides. We explored all of them. One doubt I'm getting here is ki, what is this fixed size parameter, right? So this fixed size parameter is basically telling ki what should be the size of the figure. Um, so as I had said, I mean, if you remember what I said previously, if let me just remove it. If you simply just do this plt dot bar, which will plot a bar chart, it by defaults, by default it makes a figure in the back end and specifies a default figure size. If you want to make like two, in a single code you want to make two different plots in two different figures, you have to write this figure as well. And yeah, so inside this figure, this fixed size parameter changes the size of the figure. So the first plot, which is this, I hope you are able to see my cursor as well. Um, so the first plot, which is this, this bar chart, this vertical bar chart. um, so the first plot, which is this vertical bar chart, has been plotted with the default fixed size, while the second plot, which is this horizontal bar chart, has been plotted with the custom figure size which we provided, which was 12 times 3. So 12 is the horizontal dimension, while 3 is the vertical dimension. These are, you can like try to tweak around a bit with the fixed size parameters and see like what all values you're able to get. We saw, did all the different, we explored all the major plots offered by PyPlot, matplotlib.pyplot, and we ended our session at this Seaborn thing. So Seaborn is another, let me just import it. Seaborn is another library, like it is an extension of the Matplotlib library, and it is mostly used, for advanced plotting and better user interface. Like Seaborn offers a slightly better. I mean, it's not that you cannot create it with Matplotlib, but then Seaborn has some custom settings in its plots, which generally tend to make them appear a little better in comparison to Matplotlib. So you have this hist plot which plots the histogram. You have this box plot which plots the box plot. If you know what's a box plot, it is basically, let us say you have okay yeah. So box. Let us say you have some column, right? You have some ratio type statistical variable uh, in the form of a column. If you plot its histogram, if you plot its histogram, the the histogram can actually be no in plotted as a box plot as well. Box plot is nothing but a different way to plot a histogram. What it basically does is it forms a box for the values corresponding to the range 25% and 75%. Right. So what I mean by these percentiles is basically um, you know if you have a column and you like sort it, right? If you sort it, and let us say you have a column of size 40, right? So what would be the 25 percentile of 40? That would be about 10. What would be 75 percentile of 40? That would be 30. So what it does is it sees what is the 10, so in the sorted column, what is the 10th rank value, what is the value for 10th rank, and what is the value for 30th rank, and it just makes a box over them, right? It makes a box over them. And so this box actually represents what are the primary quartiles. So these are called quartiles. We can see a brief example of a box plot. Um, we I have some random here I'm creating a random NumPy array, right? This is some random NumPy array. How I create this is basically derived from a data frame, a new data frame. We'll see in a short while what this data frame is, right? But the point is, this is some NumPy array which can be plotted. So if I just do see SNS the dot box plot, if I call the function, right? So SNS dot box plot, and this is basically y, and x is what? X is sample data. Let's see what's yeah. So it shouldn't be a string. It should be okay. Let's not do that. Let's just plot it simply. Yeah. So this is an example of box plot, right? This is a simple box plot. What it basically means is this box which you see basically represents the values corresponding to 25 and 75%. sorry, 25 is the down, 75 percentile is the up. So 25 and 75, in between 25 and 75, these are the values. Now these values are like, so the distribution is something like, let me also plot the distribution as well. Distribution is basically the histogram, right? SNS dot hist plot. Um, so if you see the histogram, which is very skewed towards zero, right? It is kind of skewed towards zero. What I mean by skewed is basically, it is kind of biased towards zero, right? However, it has a very huge range. Like it has a huge range. It's, goes till 4,000. It has values as high as 4,000 and values as low as zero. Now, this histogram is like a little difficult to read, right? This histogram, for you it might be like, okay, what's the difficulty? But then let us say I want to, measure these values as well. Okay, how much are these values? What is the number for them? So I do a log transformation over them, right? So if you remember the logarithmic transformation, and and yeah, this is not available here. So we'll do a np.log here, and this should do the transformation. Yeah. So I did a np.log, and this converted this df sales, which is basically a series, and correspondingly an extension of numpy array, into the corresponding log value. So it calculated the log value for every entry in the in the array, and then it plotted the histogram for it. So now you can see like the picture is slightly different. The picture now is slightly different. What the previous histogram was showing is the data was largely concentrated towards zero. But this data, what it is showing is, please also mark key. This is the log to the base e, right? So that's the reason for 4,000 we are getting the value 8. Let's take np.log 10. I'm sorry for the, yeah, yeah, log 10. Now it is like 3.5, right? So log 4,000 is around log 4 times log 4 plus log what 1,000 and log 1,000 is 3, and log 4 is log 2 times 2, right? Which is if you know that that's 3.6. So now you see a different picture here. Now you see a very different picture here. What you see is that the values are actually peaking at 2.5, right? 2.5 means, if you can convert it, since this is log of sales, right? So this is log of sales, and log of sales, the histogram is peaking at 2.5. 2.5 is what? It is basically, this is basically 400. So the values are actually peaking in 400, which we couldn't see in the previous histogram. In the previous histogram, we couldn't see, okay, where is the value exactly peaking? Since the range was so huge, it was very difficult for us to observe. While here we can very easily observe, okay, the value is peaking at around 400. If you have some difficulty calculating inverse log, you can just use Python, right? You can just, what is the most basic functionality of Python to do calculations? So it is like, it gave me 316, which is somewhere near 400. Right? So I mean, 316 might not appear near to 400, but given that in a range which is between 0 to 4,000, 316 is near to 400. But nevertheless, that's not the point. The point. That's not the point. The point is, this logarithmic transformation was very, good in. It could like very effectively tell us where exactly is the. So we saw this box plot as well. There are some other plots. This heat map, this pair plot. These, not very difficult to follow. This heat map we'll see later. This pair plot is not very difficult to follow. I would recommend you guys to play around a bit with it. Um, Pandas also has like some extension over Matplotlib. Like Pandas has some functionality which are basically an extension of Matplotlib. which allows you to plot data in a very easy manner. Like, so you have a plot method for every data frame object or every data frame variable. Like if you have defined a data frame with the variable name df, so you can use this method. Let me just get my laser pointer. Df.plot. You can use this method df.plot, and inside you can. This is an example code. Inside you can specify these are the column names, right? We saw an example previously. We'll saw more examples as we do some hands-on, project. As we do the hands-on project, we'll see more examples, right? These are all the same plots which we saw previously, just a slightly different syntax. Let me just proceed with the session, and we'll see this while we do the project. Yeah, next we move on to data-driven decision making. Right? Data-driven decision making involves two prime, data. We'll see what is the, we'll see the art of data-driven decision making. This has two key subjects associated called, the primary one being regression, the next is classification. Uh, so we'll see what these are. In a short while, we'll see what these are. So decision making. So the art of data-driven decision making, has two demands, right? Has two demands. Not has primarily two demands. First is the ability to collect some reasonable data or some reasonable statistical variable. Next is the ability to make estimations or classifications. Right? Estimations and classifications, we'll use them like interchangeably. Like it basically depends on um, the type of variable which we are dealing with. We saw four types of variables, which four key types of variables in statistics: the nominal, which is the class type variable; the ordinal, the class type variable, which can be ranked as well; the interval, the again a sort of a variable where you can do addition and subtractions, where addition and subtractions make sense. Then we saw the ratio, where division and multiplication also start making sense. Right. So the ability to estimate and the ability to classify are like two, similar paradigms. I mean, they are two similar paradigms. So the data-driven decision making requires two capabilities. First, to collect data. Next, to make estimation or classifications based on this. Right. So I'll edit this. Right. So next is we'll see first see regression. Right. So data-driven decision making had, if you remember, the second thing was making either estimation or classification. Now regression, the primary work of regression is to do data-driven estimation. So regression, we primarily use regression to find an estimate for a continuous variable. Please note the word continuous variable, which we name as target variable. The estimation is done by establishing a relationship between the target variable and an independent set of variables, which we call as feature variables. It is represented by X. And the relationship is, esta- um, established by regressing over past data. So the relationship is established by regressing over past data. What do I mean by regressing? Basically, looking over at past data, looking in past. Right? Progressing is like moving forward. Regressing is going back. Right. So the relationship, it might be linear, it might be non-linear, or even non-functional. But the way we define the relationship is, the way we find out the relationship is linear. Right. So uh, the when we like try to establish some sort of non-linear relationship, it is still done in a linear way. We'll see how. We'll see how. Right. So for the time being, our primary objective is to find this, find a function which maps x to y, right? And finding the function is our core objective here. The most basic relationship. Let's start with the most basic relationship. which is the linear regression. So linear regression is the most explores the most basic relationship, which is basically linear. So we assert a equation that y is basically a times x plus b. Y is basically a linear combination of the feature variables plus a constant. And the process involves calculating the value of a and b, which minimizes the sum of squared errors of the estimation and the real value. So we start with, okay, this is a scatter plot which we saw, right? This is some scatter plot, some derived from some data. Our objective is to find this line. Our objective is to find this line. And how do we find it? We find it by coming up first with a random line, and in that random line, what we do is, okay, so here the target variable is this quality characteristics. I hope you are able to see it. The target variable is quality characteristics. Let me zoom over it. Target variable is, which is y, is quality characteristics, and the feature variable is process input, right? So we are trying to map process input to quality characteristics. And so what we do here is, at the beginning we just have a straight line, a straight. We at the beginning we just have a straight line, right, like this. And then what we do is, for every individual point, we find the distance between the point and the straight line with respect to this y, with respect to this y, right? So with respect to y, what is the distance? And so and then we basically square it, right? We basically square it and add all such distances from all the points, right? From all points we find such distances and add them up, which is basically our loss. So this j is called loss, right? This j is called the loss function. This loss is a function of a and b. This loss is a function of a and b. What are a and b? A and b, a is the slope, b is the constant, right? So assuming y and x are statistical variable are containing a matrix. Like this is all mathematical expressions. I won't like go a lot inside them. So you get the point, right? What we start with a random line, and then we calculate what is the error for every point, square it, add it. This becomes a loss. We optimize the loss on the basis of these two variables, right? On the basis of these two variables. Which two variables? This a and b. A and b are our variables. So what we are doing is, we are finding the value of a and b, which reduces this error to the least. Now this is kind of obvious, right? How will you exactly find a linear line? You'll find a linear line by finding what is the value of slope, what is the value of this constant, such that we have the least error from the scatter plot, least error observed with the scatter plot. We next move into some additional details, like how we implement it in Python. We basically assume that y is a n-dimensional array, x is again an n-dimensional array, each containing all the values, right? And here we took x as having only one variable. Now please note, x can have multiple variables as well. We call that multilinear regression. So in case of multilinear regression, the x ka shape becomes n comma r. So what is n? N is basically the number of rows, r is the number of columns, right? R is basically the number of feature variables which we are considering. The coefficients and the constants are called as weights, right? In linear regression, the coefficients and constants are called as weights and are indicated by a vector theta. So the mathematical expression is y is theta transpose times x. Now please note, theta is a vector. A vector is represented in maths as a column matrix. So it's a column matrix. So I want to like find what is sort of a dot product between theta and x for every row of x. How would I achieve it? I'm sorry, not for every row of x. I have to do it like for I have to do it for every row of x. And how would I do it is basically taking a transpose Okay, I think this expression has a slight error. I won't take the transpose of the weights. I would rather take the transpose of x, not okay. The, not x. I would take the transpose of weights only, but then I'll do it like this. Yeah, this is the correct way. So please note that these are all vectors, and vectors are column matrices. Um, X can be like X is can be a table as well. So table is what? Table is a proper matrix where the outer table is a proper matrix which is like the rows, which has the rows and columns, right? So table is like a matrix only. So this is the right actually. This is the right order. Right order of matrix multiplication. Matrix multiplications are like not commutative, so you have to like ensure the order is correct. So x has a vector. Yeah. So this x prime, we define a new variable called x prime, which is basically the x, but it has a new row. It has an additional row at the bottom, which contains all ones, so that we can like incorporate that constant term as well. The code for doing this linear regression in Python has this library called scikit-learn. I think we discussed the scikit-learn. In case you don't remember, scikit-learn is a library in Python. You install it like this. You install it like this. Pip install scikit-learn. You install it like this. You run it. If it is pre-installed, if it is already installed, yeah, it should show something like requirement already satisfied. So if it is already installed, you can just ditch this code and simply import the library. The library has a different name while installing, but a different name while you import it. So you import it as sklearn, scikit-learn, sklearn. So sklearn has a submodule named linear model, which is for linear, all this linear regression and stuff. So from sklearn, you import linear regression. Now, please note how I'm writing this statement. You can, you can write it as like this. Till now, we had been doing the import library as some identifier. Now we are doing okay from that. I don't want to import the entire library. From that library, right? From that library, import this specific uh, so go into that library, get into the specific module and import this specific function for me, right? So this is simple English only, right? So not very difficult. And yeah, model is you have linear regression. I'm sorry for this dot, this shouldn't be there. Yeah, then what you do is model dot fit. You just have you have a x, which is basically the stored in the way we just discussed as matrices and vectors. You fit x comma y and then you predict it. Okay. Very easy method. So this y pred is again a vector of the same dimension as n, the same shape as n, right? And yeah, that's it. Right, it's done. That's how easy it is to do. Right, and next, before making any model, it's a very good idea to actually split the x and y into a training data and a testing data. Now, it's a common observation in machine learning that your model like tends to overfit over data. What is overfit? Overfit basically means that your model like fit a little too good over the data. How would you know this? Like, um, you know, uh, you would see that. I mean, for inspecting that only, you do this train test split. So you split your x and y into a training data and a testing data. So you train your model over the training data and you test your model over the testing data. Now, how you test your model? How exactly do you test your model? We'll see. We have some metric for that, which is the R square score. Now this R square score is a very special value. It is it's a number in range 0 and 1. Higher means better. Very simple. So you basically train the model over the training data set. You generate some prediction over the training data set, and basically compare it with the actual, you generate some prediction and you compare it with white training. How will you compare it? Using R square score, right? Now we'll see the code as well. We'll see the code. I'm sorry, I don't have the code in the slides. We'll see the code for R square score. And basically, what you do is using this R square score value, you see how nicely your model has predicted, in comparison to this white tree. Then what you do is again, then you pass this testing data set, this testing X into your model, and whatever is the prediction, you compare it with this Y test, right? And that would be what is your testing R square score. So you basically find a R square score for training the data set and testing data set and compare them. If there is a huge difference between R square score, generally in testing the R square score is smaller in compared to training. But if the difference is very huge, then you see that then it's an indicator that your model has overfit over the data. Overfit models show very good metrics in training data set, but they fail to generalize. That means they show a very poor output in testing data set. We'll see how we can do all that. Now, next question is, okay, how would I find the dependent variable? How would I find? So the most easiest method is just use the correlation, right? Correlation, if it is a statistical variable, which is basically examines the examines the covariance between two variables, and how significant is that covariance in comparison to the variance of the two variables. Like, we have two statistical variables. You can find the variance for both the individual variables, and you can find the covariance for the two. Covariance is found between two variables. So you can find the covariance for the two variables, and if the covariance is very significant in comparison to the variance of the two variables, you know that they are correlated. Correlated means there is some relation between the two variables. So you pick some target variable and you try keep see the correlation between the target variable, and you have a set of you just have a set of variables, a large set of variables, and whichever variable out of them gets very nicely correlated with your target variable, you pick them as your dependency. You pick them as your feature variables. Now sometimes there is this problem that your feature variable, the number of feature variables is very large. In that case, your model starts to behave a little unpredictable. It becomes a little unstable, and and there is a good chance that it will overfit. In those cases, you use something called dimensionality reduction. What it does is, let us say you have like 13 columns of 13 feature variables, and you don't want 30. You simply just reduce them to three feature variables. Now, three feature variables which can somehow encode the data of all those 13 variables. So that is dimensionality reduction. It's a very good thing to do. Firstly, in case that you have a lot of variables, then you can do dimensionality reduction. Next thing is, if your feature variables correlate very nicely with each other, like if your feature variables correlate very nicely with each other, then also you should like either drop one of them or just use dimensionality reduction. Feature variables shouldn't correlate with each other. And the final thing is, yeah, correlation does not mean causation. Now, many people like confuse with them. Yeah, many people confuse with between correlation and causation. What is causation? Causation is like cause. Okay, something is causing something. Now, when we see a linear relation between two variables, there is a natural tendency to think that okay, one of the variable is causing the other. To give a short example, I'll say okay. Let us in case of summers, like temperatures would be very high. So when temperatures are high, generally in houses, what we'll see ki, all our fans are operating at a higher speed. Definitely, right? We might want to operate our fans at a higher speed when there is summers, when the temperatures are high. While we will also see that if we'll pick up an ice cream, if there is summers, if the temperatures are high, the ice cream melts very fast. Right? So you have three variables here. Honestly. One is what is the surrounding temperature. One is what is your fan speed, and one is how quickly your ice cream melts. How quickly means what is the time taken by ice cream to melt. Right. Now, here's a short exercise. Okay, which type of which variable is which type of variable? The answer is okay. First is your surrounding temperature. Temperature, matlab interval type variable. Fan speed. Fan speed is something like which is sort of a review of movie, right? Fan speed is like a review of movie. So fan speed is a ordinal type variable. And finally, we have this time required for ice cream to melt. Okay, yeah, some people have doubts with um, how you use those tools. Yeah, exactly. That's why we have this project. We'll be doing the project in the remaining part of the session, and you will be very clear with how we use all those tools. But then let's continue with our discussion. So here we were talking about three variables: the surrounding temperature, which was an interval type variable, the time taken by ice cream to melt, which was a ratio type variable, since it is time, and finally, which we had you know, finally we had the speed at which we are operating our fans. That was an ordinal variable. Now, generally, you will observe generally you will observe key uh, with high temperature, surrounding temperature, we operate the fans at high speed. When low temperature, generally we operated the fan at low speed. Similarly, at high temperatures, the ice cream melts very fast, while at low temperature, the ice cream melts slowly. Right. So with temperature, you will see a correlation with fan speed, and temperature. You'll see a correlation with time taken for ice cream to melt. What correlation? Matlab, you'll see some relation. Okay, you'll see a sort of linear relation. Okay, when temperature is very high, generally people prefer high fan speed. When temperature is low, generally people prefer low fan speeds. Right. So you'll see correlation between temperature and fan speed, temperature and time taken for ice cream to melt. Similarly, you'll also see a sort of correlation between ice time taken by ice cream to melt and what speed, what fan speed people are operating their fans. Right. Now, this correlation, the final correlation which I talked about between time taken for ice cream to melt and fan speed, does not imply a causation. Right. The cause is the high temperature. This is just a correlation which you observe, or sort of relation which you observe, but this does not imply causation. Right? Causation is temperature. Cause is temperature, and temperature is influencing these two variables to like correlate with each other. Now, right? So, how you actually establish causation? Causation is established. Matlab, you can there are some mathematical techniques which claim to establish causation, but then the 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 most robust method is your brain itself. Like you only say, ki, okay, just think, ki, okay, you see some correlation between these variables, but is one of them the cause of the either? Right? So is one of them the cause of either? Now that's like again, it requires some domain knowledge, and it requires some thought, right? So modeling is actually like it's sort of an art, and it requires a lot of thought. Right? It's a combination of science and art. So yeah, that basically summarizes what I have to tell about correlation and causation. Moving to the next slide, yeah, dimensionality reduction. I talked about dimensionality reduction in my previous slide. Dimensionality reduction, the primary method is PCA. PCA is a very robust method. It is very widely used for reducing dimensions. Dimensionality reduction method. If you have 13 columns, you want to like convert it into 3 columns, which somehow encapsulates the meaning of all those 13 columns. You use PCA. Right. The mathematics behind PCA is maximizing variance, and the method of doing it is basically you know finding a sort of covariance matrix between the variables and finding the eigenvectors corresponding to three largest eigenvalues. But this, I mean, I know I'm like throwing some information over you, but then this, this is slightly beyond the scope of our session, and I would encourage you guys to, if you're interested, go behind the mathematics of PCA and linear regression. Um, so before doing, this is the code for writing PCA. Before doing PCA, you do a standardization of the data. Right. Why do you do standardization of data? Because PCA is heavily influenced by the scale of data, right? PCA gets really influenced by the scale of data. That's the reason you do standardization, right? So your data can have any number of columns, but let us say you have to reduce it to 2 columns. So you define this PCA, okay, and okay, I forgot to import PCA. Yeah, so PCA was imported here. Yeah, escalon dot decomposition. So what you do here is so before anything you have to like import these stuff, standard scalar and PCA. I hope you remember how you import standard scalar. For importing PCA, you have to import from escalon dot decomposition import PCA. Right. So this would import PCA for you. So this is the code. This sort of is self-explanatory only. You have to like okay, I'm sorry. Yeah, so this principal component is your new matrix, your new feature matrix, which is like of a dimension. The number of rows are same, the number of columns are reduced to 2. How you create this, this updated matrix is by using PCA dot fit transform. So you just input this scaled matrix inside it, and this would give you like this would convert it into the reduced matrix. Yeah, yeah. Hello, folks. Yeah. So classification. Next is classification. So regression we do for continuous type variables, the ratio or interval type variable. Classification is done for nominal or ordinal variable. So if you want to like sort of have some forecasting or estimation for a nominal or a interval type variable, we do classification. Um, the classification is done, using some again some independent variables. Here the concept is also same, that you have a target variable which needs to be classified, and you classify it using some feature variables, which feature variables can be continuous and non-continuous as well. Now non-continuous, like there might be some complications when with non-continuous and discrete feature variables, but in general we like we'll stick to continuous feature variables, right? So classification, we generally do it we generally do classification when our target variable, yeah. So we generally do it when our target variable is of the nature of nominal or ordinal. right? And our feature variable is, I mean, we assume it is to be continuous in nature, but it can be non-continuous as well. Right? It can also be like nominal or ordinal as well, but that is like a little more complicated. We It's sort of a little out of scope of our area. The objective is the objective is classifying the target variable, and what all things we use. We use, I mean, how do we model it mathematically? We use a function. We use a special function called the sigmoid function. Yeah, so this has to be minus. I'm sorry for this typo. Um, we use a sigmoid function to do the modeling, right? We'll see how we use it exactly, and we use the loss which was previously a mean squared I mean the sum of squared errors. Here we have a special loss called binary cross entropy. Now what these are, we'll see here. So this is how we do it. um, the We still try to establish a linear relationship. We take a linear combination of the feature variables with the weights. Now again, this is like, yeah, so this is the correct. I'm sorry for this. Yeah, x times theta. This should be the correct matrix multiplication. Yeah, I'm sorry for this error. Typo. So how we basically do it is, yeah, we take a linear combination between the feature variable and the weights, and we pass the layer that through the sigmoid function. So if you like think of it, we have like think of it as a table. Like we have a table, rows, columns. Columns are like, for every row you basically multiply the values of the row with the weights, right? With the weights, you multiply the values of the row with the weights, and that would give you what? A single column. Yeah, so okay, I'm sorry. So we multiply the value of the rows with the weights and we take a sum, and that would give you a single column, if you can think of it. So we have a table, we have multiple columns, we have multiple rows. For every row we take the value, we multiply it with the corresponding weights, right? Weight is multiplied by element wise multiplication. Then we do a summation, and yeah, then we do a summation and store it. So for every row we do this operation, we'll be ending with a single column with the same number of rows, and we pass that single column through the sigmoid function. So this would again return me a single column with the same number of rows, but the values of every row has been passed through the sigmoid function, and this is my uh, output of the model. Now the loss function here, which is again a function of the parameters of the model, is basically, this is called the binary cross entropy loss. This is the binary cross entropy loss, and minimizing this loss results in optimal value of vector theta, and we get this decision boundary. So this is like, the feature are x1 and x2 are the two feature variables, and the y is basically a binary variable. Y is a binary variable. So generally logistic regression, classification is generally shown as a binary classification problem. Even if there are multiple classes, we still try to model it using a binary, model it as a binary classification problem. And yeah, so that requires some thought, which you will see as you practice some more, um, you know as you practice some additional um, projects. Like you have to do some projects, and you will see how all the different methods you can do classification. So yeah, so here our features are x2, x1 and x2, and the target variable is this blue and red. Whether x1, x2, we have this sort of starter, we have this sort of scatter plot, and we have to basically colorize each point. So each point we have to predict whether this point would be a blue or a red point, right? We have some primary data, like we have been given some data which shows ki, okay, this point is blue, this point is red. Now what our objective is to find this decision boundary. Our objective is to find this decision boundary. Now here it might look a very easy task ki, okay, yeah, this here is blue, here is red. Naturally the decision boundary is like this, we can just draw it with a scale as well, right? But let us say we were dealing with a three-dimensional plot. In that case, the decision boundary would be a plane. Let us say we were dealing with a four-dimensional plot. Four-dimensional plot, the decision boundary would be a three-dimensional plot in that case. If we had a five-dimensional plot, the decision boundary would be four-dimensional. So the point is that as a human, we cannot like really see the decision boundary always. So for this purpose, we develop algorithms which do it for us. So this is sort of an algorithm. Now, yeah, metric. How do we assess whether our logistic regression is correct or not? I mean, how accurate it has been. So for that, so this is again an example of binary classification. There are two classes, 1 and 0. This is the actual data, right? This is the actual column which was there. This is the actual column for the target variable, and this is the predicted column by the target variable. So we made some model and we made it to do some predictions for us, and this is the predictions, this is the actual. Now this matrix is called a confusion matrix. This matrix is called a confusion matrix. If you see, the values inside it is like, the spike means where actual is 1 and prediction is 1, where actual is 1 and prediction is 1. So all the the rows which have been like colored with this light orange is this. Actual is 1, prediction is 0. Actual is 1 and prediction is 0. This. Actual is 0, prediction is 1. This. And there was one more, I think. Yeah. So actual is 0 and prediction is 1. These two are the rows. And actual is 0 and predicted is 0. I don't know, it didn't get saved. Yeah, so where actual is 0 and predicted is 0, there are two such rows where actual and predicted both are zeros. So these are called true positives, these are called false negatives, false positives and true negatives. I mean, as the like the name suggests itself, like false positive, actually 0, but your model predicted was 1, right? So actual it was like some negative value, but your model actual it was like negative, but your model predicted is as positive. So it is like false positive. Like even in COVID, like if you remember, there was this false positive errors with every testing apparatus, which basically means what? He actually the guy is like not no, he or she is not suffering from COVID, but then the testing method actually predicted that he or she was first suffering. Right? So this is false positive. Similarly, you have a false negative error, and you have so these two are errors. Like false, wherever you have false, that's error, and wherever you have true, that's like correctly predicted. So this is called a confusion matrix. Now, with this confusion matrix, okay, I don't know why didn't got saved. Um, okay, I'm sorry for this. Yeah. So using this confusion matrix, we actually come up with some they come up with some matrix, right, to assess the how good is this prediction. Now this confusion matrix, we come up with the first parameter we come up with is called precision, which is basically the true positives. Right, precision is basically true positives divided by true positives divide plus false positives. So I'll just write it. So precision is true positive divided by true positive plus false positive. So out of the ones which it predicted, how many were correctly predicted? Right. So precision means that, and we then have one more parameter called recall. Recall is true positive divided by true positive plus false negative. So out of the total which were correct, so previously it was out of the total which were predicted to be correct, how many were actually correct? And next we have recall, which is out of the total which were actually correct, how many were predicted to be correct? Right. So this is recall, and then we have another here as well, another parameter as well, which is basically called F1 score. F1 score is a harmonic mean of precision and recall. So F1 score is a harmonic mean of precision and recall. Right. So this is the F1 score. So F1 score generally, all these three come in a range between 0 and 1. The higher the value, the better is the prediction. So a high precision, okay, a high precision but a low recall means your model has overfitted. Like, it has sort of overfitted with the data. High recall and a low precision means your model has like overgeneralized. It has, it has sort of underfitted. Right. So in this case, we have like this F1 score. Generally, when your precision is high, your recall becomes a little low. And when your recall is very high, the precision becomes a little low. So F1 score is basically a harmonic mean of precision and recall. And it is again between range 0 and 1. The higher the value, the better is your prediction. So since like we have like a trade-off between precision and recall, we try to maximize its harmonic mean. Right. So this basically summarizes the logistic regression, and yeah, have some problems as well with logistic regression. The primary problem is that the problem of imbalance. Right? The primary problem is the problem of imbalance, where you have like two categories. Like you have two categories, but then one category is like very large and one category is like very small, and you have to do the classification between them. Right. So how do you exactly do it? How do you tackle the imbalance? What you do is you just randomly resample this category. Resample means you just randomly pick a value and you duplicate it. So you randomly pick a value, you duplicate it. You keep duplicating until this category 2 becomes as large as this category 1. Right. So this is one of the ways of tackling imbalance. The other way is you just like when you're tackling imbalance, like if you like think of it a bit, um, it's quite logical that the data which you have collected should be like very generic. Like it should contain all the possible cases for which can occur. Right. If you like collect poor data and then you keep resampling, your model wouldn't be good. Like your model might perform good in your data, but then if it gets like some external um, case, it might fail. The other problem is of high dimensionality. For high dimensionality, we use something called latent Dirichlet allocation. It was again, devised by the famous professor Andrew Ng. LDA is sort of like PCA. We'll see the code for it in a short while. Again, like the idea is very similar, each of them. But in either cases, like we saw this scatter plot previously. Now let us say our this red dot, they were like restricted between this zone only. Let us say they were not restricted to this zone. Let us say they were like going way beyond this zone. Like so you see the problem there. Like you see the problem. If this red was like very large, it could if this red was like scattered in a very large domain, it could have like take this decision boundary more towards this red value. Right? It can take this boundary more towards this red value, and like this would the result would be that your model becomes slightly poorer. Right, your model becomes slightly poorer. So for this reason, you might now be able to appreciate why we have all those, excuse me, why we have all those scaling methods, right? So you scale both these variable in the range 0 and 1. Right? You scale both these variable in the range 0 and 1, so that like your model does a decent job in classification, right? So with that, we have completed the session, right? The session, all the topics in the session which were supposed to be covered in the session, we'll now jump directly into the project, right? So yeah, so we would be using two primary data sets. I have given you the link for both the data sets. One of them is one of them is a data pre-processing project. We'll see if we have time. We'll approach it. The other is the store sales forecasting project. This we will be doing right now. This we will be doing right now. Please download the store sales for forecasting from this link. Right? One of the link is for the store sale forecasting. Please download it and add it to your collab notebook. Right? Add it to your collab notebook. Now I think I have shared. I mean, you should be having this notebook with you. The link of this notebook has been shared. You should be having that with you. Just copy this notebook, right? You can copy this notebook by going into this file and looking for, like, you should get a option of copying this notebook. Save a copy in drive, like save a copy in drive. That should save a copy of this notebook in your drive, and then you can like edit that notebook at your end. um, so we'll see now. We'll take this store sales project. Right. So this store sale project, what the first thing is that you should have it in your collab file. Should have it in your collab file as the first step. The next step is what? The next step is you start by reading the. So it is a CSV file. If you notice, this is a CSV file, store sales forecasting.csv. And the first step is we read it in pandas. We read it in pandas, and it has some encoding issues. So please ensure you have this keyword argument with it. So if you don't have this and try to execute it, it gives some error, right? So generally, when you get some these types of error, you should add this keyword argument, and this would like this won't give any error afterwards. So let's start with some data analysis. Let's start with df.head, like df.head. Um, right. So this is the table we have. It's a huge table. Let's see df.shape as well. Let's see df.shape, and so this table has about 21 columns and about 2121 rows. So 21 columns and 2121 rows. So this is a huge data frame. But then there are, I mean, if you compare it with general VA, it's not as big. It's still a small data set. Yeah. So yeah, hi. We first see the, we have like a brief overview of the table, but you will see here key this dot 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 means it does not show all the columns present in the table. So to see what all columns are there, I'll just do df dot columns, and this should show me the list of all the columns present, right? So there is this row id, which not very significant. There is this order id, again this is not very significant. The significant ones are this order date and this shipping date, right? So what is the order date and what is the shipping date? What is the shipping mode? What is the customer ID? Now shipping mode is again not that's sort of significant, but you know might not be very significant in what we will be trying to do in this project. Um, this project is basically, I mean, this data set is about a store. Like there is a store, and it gets some orders, it ships them to the customers. It you know tracks down all these details for us, the order date, when it got the order, and from which type of customer it was, customer's name. Now that's not very useful, or what segment of customer it was, what country the customer resided in, what city the customer resided in, postal code and stuff, which is not very important. The important stuff is here, sales. What sales, what how much did the store earn from that order, right? So how much did the store earn from that order? This is what is like important to us, right? And this is what we would be like trying to forecast, or in short predict. So we will be trying to predict how much would be the sales of the store, how much would be the sales of the store. This we would be trying to forecast. Now this is some machine learning would be involved in this. So let's go to so first step is key. Now please note key, we have some date type data type. So this is a date type data, like, so this is some date type data. So by default what pandas does is key, it assigns order date. It assigns a, if we try to access its data type, we see that pandas has assigned an object type data to this order date. Now we have to convert it into a date data type. Now pandas is a very strong, very powerful date data type, which can which has various functionality, and it makes your life very easy. So for doing that, we have this function pd.toDateTime, this method we have, and we pass both our date columns inside it, and this would convert it into the a date type column, and this gets assigned to this the previous column identifier. So this is how what we are doing. If you are able to understand, what we are doing is we are accessing a column, converting it into the converting its date type, and the converted column we just reassign it to the same column. So if we now access the, let's execute this. Now if we access the data type, we have something which basically represents date data type. Now this date data type has various functionality. The first one being key, you can actually convert, access the month, extract the month out of the date data type. How you do it is key, you just write this dot dt, and then after that you just put a dot, and then you access the month, right? This is a month attribute. So what we are doing here, we are creating a new column in that which we are storing the month of order date. So which is in what months a specific order has been made, and you see that a new column has been added to our data, which is basically the month. So to access any functionality for the date data type, we have to write this dot dt. In the next step, we will see how how we can create a another column. We'll create one more column, which would be the year column. So for order date, we will now be trying to access which year the order was placed, right? So we do it and we have do it in a similar manner. So we have, you know, one more column created, which basically signifies which year was the order was placed. Now, assuming whenever the order was placed, now generally this is how it is done in companies. Generally, the orders when the orders are placed, the payment is like pre-made. Like the payment is made first, and then the order is shipped. So the payment is made first. So whatever the sales the store has made is made on this date, is made on the order date. We'll assume that, right? And next, what we do is so with that assumption, we basically plot what is the total sales done in a particular order date. Now, this is what we are supposed to be like, predicting. What is the total sales that would be done on a particular date? Now, why that is like important? Now, um, if if you like know what would be the sales, expected sales for a particular day or for even a particular week or a particular month, we would be like, you know, if you know what how many orders will be coming to you, you will accordingly keep the inventory or the stock. Now, let us say like you didn't keep the inventory and you had more number of orders, you will like fall short of inventory, right? Then you won't be able to convert every order. So that would be a loss to you. So if you had the inventory, you get the orders, you get the profit. So generally, this is a common practice in industry that they try to predict their sales, they try to predict their number of orders, and accordingly stack up their inventory, right? And like if they also know how much sales they will be doing next month, they will also have a rough estimate of how much profit they will earn by next month. Accordingly, they can like show that profit and take some loan now and you know grow their company. So these are like strategies of, used in companies. So now let's just see what is the total sales in a particular day. We do that by order date, group by order date, sales, sum, plot. This tells me what is the number of you know sales done, total sales done on a particular day. We Let's use our favorite fixed size parameter and plot it a little large. We can like plot it any large one. Like now we have a huge plot here and it shows very nicely on what day, how much was the sale. Now next we try to next we are trying to see so what is the total sales on a particular month. Now why do we try to see that? Now why do we try to see that? Generally it's a common practice in forecasting is aggregate forecasting. So what we do is we yeah, so I got a doubt what is the tool name which we are using? We are using pandas. We are using pandas. If you see, we have imported these here. We have already imported these here. Let's not use sklearn now. We are using pandas, NumPy, and Seaborn. Right, and I mean this was also there in the as well, right? So we are using pandas, and in pandas we the next okay. So in forecasting, it's a general practice that we go for aggregate level forecasting. So we forecast what would be the total sales in the next year, and using that we'll try to forecast what would be the you know um, we'll try to see patterns in we'll try to see monthly patterns, and accordingly we'll see okay, well, next year this would be the total for revenue, and we just distribute that into month by seeing the monthly patterns. So here we are actually trying to see the monthly patterns, and by doing this we see okay, December is the 12th month. So in December generally we have a higher sales generally. But then this is not entirely correct because we are like doing a blatant sum. Our year has multiple years ka data. It has multiple years data from multiple years. So what we should ideally be doing is okay, we sum up the total, um, you know, the total revenue for a month. We take a sum, but we average it across years. So we see what is the total revenue in December in 2014, 2015, 2016, 2018 as well. And then for all those different years, the total sales, we just take the average of them. So the right method of doing that is basically this. Yeah, so let's just do it here. So the right method is we group by both year and month. We group by both year and month, and we do a sum. Right. We do a group by for both year and month, and we do a sum. So let's see what that gives us. Right. So let's see first what that. Okay. Let's see first what that gives us. So we are doing a group by year and month. So first we'll group by month, then by year. Right. So you can actually do a group by for multiple columns as well. Let's see what this gives us. So this gives us 2014 May for month one. What is the total sales? Right. Since we are doing sum for month two, what is the total sales? For month three, what is the total sales, and so on. Similarly, we have similar observation provided for every year: 2015, 16, 17, yeah, 17 till 17 again. If we plot that, if we plot that, we get a good plot as well. कि 2014 January से लेके 2014 November तक this has been the total sales per month. Similarly, 2014 November से 2015 ये तक this is the sales. Now, generally, you see कि in December the sales peak, right? And there has been an increasing trend as well. Over the years, the sales have been increasing, and the sales generally peak during December. So you see there are two aspects to this data. One is there is a trend. So there's a trend key the data like the total sales are increasing over years, and there is a seasonality. There's a seasonality key, okay, this generally during December the sales peak. Now why does it peak? Christmas. Now this is like some this is extracted from some Western nation, perhaps like America or London, perhaps. So during Christmas, people there generally do a lot of shopping. Right? So any say, shop would have its sales peaking. Right? So if you want to see the trend is yearly. Trend is not monthly. Trend is yearly. For trend, we see how we do it is basically we take the total revenue sales for every year and plot it. So we group by year. We take the sales column, we sum it, and we plot it. So we see that. So this shows the trend. Like this shows the trend very nicely. This is showing the trend. We, you know, in 2014, the total this was the total sales, while in 2017 the sales shot up to beyond 21, uh, 2 210 thousand, right? 2.1 lakhs. Um, now again so yeah, now what we do here is we uh, we see the previous group by we did. We group it both by year and month, and then we again group. So we did a group by sum, then we again group by. Now we group by level one. Level one means we now group it by months, and we take the mean of it. So what that should give me is the for every month, what is the average sales across different years? So for every month, what is the average sales across different years? This is giving me yeah, for every month, what is the average sales for different years? And if I try to plot it as well, this is what I'm getting. So this is a monthly pattern. right? This is a monthly pattern. Now, if I know the the total sales which is available in a particular year, I can very effectively predict what would be the monthly sales, right? I can very effectively predict what would be the monthly sales. And if I can predict the monthly sales, can I go a one step down? Like, let us say, can I go one step down to you know weekly sales? Let us see. Let us see whether we can do that. So let's have one more column, week, day. So this is like which week it is of the uh, you know which week it is of the year. So this should um, but then yeah. So but see, now you can like observe one problem with this idea. Now you can observe one problem with this idea. This the problem is that in every month there isn't a single like fixed amount of fixed number of weeks, isn't it? In every month there are no fixed number of weeks. So weeks are like there are 52 weeks. They can be like they are not evenly distributed in all months. So what instead we'll see ki, we'll try to exploit this other parameter, which is the day of week. Now which day it is of the week? Day of week. So which day it is of the week? So it is like it gives me a value between 1 to 6, 1 being I think yeah, sorry, 0 to 6. 0 being Sunday and 6 being Saturday. Like Sunday, Monday, Tuesday till goes till Saturday. Right. So this would be the next level in which we can like go. So the first level is uh, you know doing a linear regression. The first level is doing a linear regression at the annual level. So at the annual level we can do a linear regression. Now let us see how we can do it. Let's bring this data here. Right. So let's bring this data here. Yeah. So this is what we are supposed to be predicting. The what This is the y. The y is this column. This column is my y. If I do the values, then this would be my y. What would be my x? My x would be right. My x can be anything. My x can be 2014, 15, 16, or 17, or it can be a simple 0, 1, 2, 3. It will still work. It will still work very easily. Now we import all the um, the libraries from sklearn dot linear model import linear regression. Now let's import it as some identifier. Now we make the model LRS. Colab automatically does all the changes for you, right? So yeah, you made this linear regression. You have this numpy dot array doing all. You convert this x into firstly a numpy array and you reshape it into -1 and 1. So this is very important. Um, Generally, before doing linear regression, you have to pass a column, a column array. Now, if I do this numpy array over x, right? Numpy, yeah, x is this. Let me just put it here. We haven't yet executed the code, so this gives me a one-dimensional, array. Now, how sklearn interprets this is it interprets it as a column as a row matrix. So you have to like reshape it using -1 1, and this will give you a column matrix. This is a sort of column matrix. NumPy, sklearn expects all column matrices. Right. So this let's execute the model. We made the model. We made the first model. Right. We made the linear regression. Now let's make the model predict some values. Let's predict it. Make the prediction over x only. Right. Whatever x we had, let's make a prediction over it, and let's plot that x comma this thing, and we'll also plot the y as well. Right. Now, please note that I haven't created a new figure here. So what this does is, oh, we haven't even imported matplotlib. So let's just import matplotlib. Um, Now I'm importing matplotlib here because just for the sake of uh, you know keeping my code organized. You can import this anywhere in your code you can import this, but please make sure wherever you use this, it should be imported beforehand. Right, so let's go to our plot, wherever our plot was. Yeah, so this blue line is the predicted value, and this orange line is the actual value. Now you can see that this predicted value very closely resembles the actual value. We can like have some additional parameter here. This label, this is my predicted prediction, and this is my actual. Now this label, what it does is it helps you add a legend. This legend means it's an additional information in your uh, plot which shows ki, okay, which line is what, right? Now if you want to like see what is the R square score, so for R square score you use this model dot score, and inside you just put this this x dot reshape, and this y is your target, and this is your x. Okay. So what it does is using this x, it finds the predictions, and it finds the R square score between those predictions and this y, right? Predictions between, sorry, um, R square score um, between y and the prediction of model over x. So this would give me, let me print it as well, right? So this gives me an R square score of 0.98. Now this is a very good R square score. Generally, an R square score beyond 0.7, 0.8 starts, is a good R square score. 0.9 is like very good. 0.9899 is, it almost like resembles it very closely. Now let us say I made the predictions. Now let me store it as as a variable called pred. Pred is basically, you know, it's storing all my predictions. Model.predict. Let me store it here in this variable called pred. Let's keep this for later. So yeah, now our objective is to go on a on a step down. Now we made year-wise predictions. Now we can go for monthly predictions. Now monthly predictions, how we'll do? We'll use this. Yeah, we made. We'll use this chart we made. Now using what we'll do with this chart is we'll just copy the values first. We'll copy the values first, and yeah, this is the table which we have. Okay, I think we didn't copy it entirely. So yeah, we'll copy this entire stuff here. So this is the table which we have. What we'll do is we'll basically normalize it. will basically normalize it, which will give me a factor. Now let me store the values here. Uh, Facts. Now, how will I normalize? I normalize it using facts dot max minus facts, right, divided by facts dot max minus facts dot mil, right. So this basically, gives me a factor. This basically gives me a factor. Then, okay, I don't think this would work. I think this would work. Facts divided by facts dot sum. Yeah, this is the factor which we are looking for. So this is a factor which we are looking for. Let's display this factor. So this gives me, an array, right? An array which basically stores key on which month, okay, on a particular month, the total sales on a particular month, how much is it as a ratio of the total sales over that year. So what this the array stores is key any particular month, its sales, what factor it is of the total sales of that year. If you can, if you're able to understand. Now what I'll do is I'll multiply this facts with this spread. I'll multiply this facts with this spread, right? And how I'll multiply is I'll basically reshape this spread. Now I'll first have to see okay, what is the shape of this spread. The spread is a one-dimensional data. The spread is a one-dimensional data. So I'll have to reshape it by doing -1, 1. Now this will reshape it into a two-dimensional data. Right? Now this two-dimensional data I'll multiply with facts, and you'll see what this does. So what this does is now imagine this as a single column of a table, and this as a single row. This facts as a row. So what it does is this takes a single value of that column, and it multiplies it with every values of the rows. It multiplies it with every values of the rows, right? So if we try to see the shape of it, 4, 12, right? So what it does is let me just show it here. It will take first this value and it will multiply it with every value here. It will multiply with every value here and correspondingly store the value. Then it will take the value this and multiply with every value here and store the value. So in this way it operates, right? So in this way it operates. So by doing this, now if you realize what we have done is, by doing this we have made a prediction. We have made a prediction for every month of every year. What would be an estimated total sales? What would be the estimated total sales? Now let me plot this here. Right. Let me plot this here. Now this is basically plotting for every year. What is the total sales for every month? We calculated something similar here. Right? We calculated something similar here. Let's plot this as well. Let's convert it into a data frame and see what it. Oh, sorry for the typo. Yeah. So we again have something. Let's just plot it. Oops. Yeah. So this is the prediction which we have, and this is the actual value which we have. Now let's see them on the same graph. So let's see them on the same graph. Okay, this does not plot it. So if you want to see them on the same graph, you have to like use store this, and this is the method how you do it, right? Now this is a slightly not very good way to visualize. So what I'll do is I'll put a alpha here and put a zero point 0.2 here. So okay, this became a little too faint. So you get what alpha is doing. Alpha is making this these four lines. It's making it fainter. If I put a zero point 0.5, it's still pretty faint. 0.7. No, yeah, now it's sort of visible, right? So this is like so this zero is for this violet line. This zero, this blue line represents this violet line, and this orange line, orange line one represents this brown line. This green line represents this pink line, right? Now, while you might say, ki, okay, this is not very accurate, but then if you like compare it, like the scale, the scale of the data, if you compare it with that scale, you can like come to this conclusion. Okay, like this is still pretty accurate. There is some issue here. Yeah, so there is some issue here. Let me just see why this issue came. Yeah, so it is starting from 0 while our months start from 1. So let's just set index, and the range is 1 comma 13. So let's try it like this. Yeah, so these are not there in the columns. So what you'll do is, okay, so this is my data. We'll save it in some temporary variable enter, and we'll just change the index of the enter as list range 1 comma 15. And now let's display enter. Yeah, so now you see the index has changed. So previously we'll see what is what was enter. Yeah, we have to display it as well. So previously it started from 0, now while now it is starting from 1, right? So yeah, these are some ways you have to like manage the data set. So here what we'll do is we'll do enter dot plot. Yeah, now it is looking a little better. Yeah, so there was some issue with that. Now it is looking a little better. Let's just play around with some parameters. Oops, sorry for that typo. Yeah, so now you see all the predicted lines are like dotted while all the actual lines are rigid. Let's have some alpha here so that you can see little nice visualization. Okay, doesn't really make a difference. Anyways, you get the idea here. You get the idea that our idea was to make predictions, monthly aggregate predictions. So what will be the total sales for a particular month? And we did that in a pretty easy and pretty easy manner, right? We did it pretty easy. So right, so this basically concludes the project, right? So I would I would definitely encourage you to download all these data sets and play around a little more over it, right? So this was like a 5-day boot camp. So we still covered a lot, but then there is still some stuff remaining, which is like not really which is not something which can be learned from an educator. Rather, it is something which is sought to be learned from practice. So what I would heavily encourage you to practice these you know the stuff which we learned, right? There is one more code as well, which again I would like um, encourage you to practice from your own. There was one more project which we cannot like do it now. So yeah, with that, it basically summarizes. We conclude with the boot camp, right? I hope you guys were had you guys had a good learning experience. I hope you guys had a good learning experience, and okay, so there's one doubt, whether you use linear or logistic regression. If your target variable is continuous in nature, use linear regression. If your target variable is class, nominal in nature, right, use logistic regression, right? So this is what is the primary difference between classification and regression. There are some additional, I mean, if you have any additional doubts, please do post it. So this basically like concludes this 5-day boot camp. We we basically we covered a lot. We covered a lot. We covered like we started from basic Python, and we went till we started from basic Python. We saw how we can use loops, how we can use functions. Then we went into different modes of storages Python provides, different data types, and then we went into more advanced data types which were offered in different libraries like NumPy and Pandas. We also saw how we can use those libraries in a very efficient manner. We also saw some basics of data analysis, data preprocessing, data handling, and data visualization. And finally, we explored how we can, having learned all those stuff, how we can employ it into some sort of modeling. Right. So that concludes the boot camp, the 5-day boot camp. I'll share the slides. I think the slides were shared previously as well. So yeah, but then I'll share the complete slides with you so that you can like see them at your own um, at your free time. And yeah, so so the problem, I get one more doubt. Okay, whether we use linear or logistic for our problem. So for in our problem, we were predicting the sales. So we were predicting sales. Sales is, if you think of it, sales is a ratio type variable or a continuous variable. So for this, linear regression is the best way to solve it. Right? Linear regression is the best way to solve it. If we were like some predicting something like okay, will whether sales will go up or whether sales will go down, so that is a problem for logistic regression, right? So yeah, that which thanks for yeah, to do case study. I'm not able to get what case study. Yeah, definitely. I mean, if you guys have more questions, please to ask it. Some guys have questions over imbalance. I think that question got like answered. So imbalance generally like there are several methods to counter imbalance. Now this is not case study regarding data. Yep. So anyways, imbalance cannot be like count. There is no particular method as a there is no particular method to counter imbalance. Uh, you like there are some tools which are there to do it, but there is no algorithm for it. Like you have to have a look over the data. You use some parameters to see key. Okay, to explore imbalance, you see some parameters, and then you accordingly like I mean, it's based on your judgment, whether the data is imbalanced, and whether you have to like add more data in it, or you just you know you just upsample your mm, imbalanced class. Can we use classification case study? Yeah, case study regarding data. Case study regarding data is like, okay, what case study you want to? Case study of a company, yeah. So we did a minor case study over a company, right, where we generated some random data through which we could still get some, good trends. But yeah, that there are multiple case studies like that available in internet. If you want, I can generate some on my, um, you know, I'll generate some additional such data sets, such case studies, and send them to you. Can we use classification in regression? Well, regression, if you like, see what exactly regression means is regression means you see the previous data. You go back in, you go back, see what is the previous data. Accordingly, you make your decision. Regression means that. When you are doing regression in a, you know, that is what means regression. Now, the classification is also sort of regression. Like these are very the boundary between classification and regression is a little fuzzy. Classification is basically when you look back and classify a nominal variable. And regression is where you look back and estimate a, continuous variable. Continuous matlab, numbers which have specified intervals, numbers where you can like multiply or divide. Um, Classification is primarily for nominal variables. Nominal variables is like class type variable. Like okay, in we saw a case study where we were seeing some jobs were randomly assigned to Ram, Sita, Gita, Sham. Right now, let us say we had some additional data through which we could like make a model which predicted okay, this is the type of job, this is the time requirement, and this is the potential revenue you can get out of it. Now, whom to give that job, right? Whom to give that job? That can be a very interesting case study, and to solve that case study, you use logistic regression. Uh, where do we get the certificates? Chorizo, Chorizo, yeah, Chorizo would be, contacting you for that. Like if you have attended all 5 days, you'll get your certificate definitely. Um, Next is did data mining. Okay, is data mining part of data science? Yeah, I mean, you have to first collect data before doing any data science. So you have to first like mine data to do data science. Like data scientists, now that's not very much a part of data science, but then I mean, you have to acknowledge the fact that these boundaries are very fuzzy. Data science, data mining, data analyst, data science, all these are like complementary domains. So if you are a data scientist, if you aspire to be a data scientist and you don't have any data, you won't be able to make any modeling or do any analysis. Similarly, if you are a data analyst, did some analysis, but then at the end, it's the our aim is generally to convert that analysis into some sort of decision making model. And without analysis, you cannot make any decision making. Right? So all these are complementary fields. I mean, anything can be part of anything. So yeah. But then yeah, generally data mining is like not very much a integral part of data science. But then data scientists do data mining sometimes as well. Referral code for that you have to contact Chorizo, Smile. What is the job market of data analytics belong to data science? Right? The question is not really clear to me, but let me um, present what my interpretation is. The job market of data analytics belongs to data science. Well, data analytics is a part of data science, right? Data analytics is a part of data science. I mean, as I said, there are specific roles as well. Okay, this mm, this guy does only analysis, this guy does only data, I mean machine learning model. End time of boot camp, yeah. I mean it's already concluded. The session is already concluded. You guys are free to mail. I would highly recommend that you stay and be a part of this discussion. But then if you're like want to leave, you're free for that. Uh, so yeah, data analytics is a part of data science only. Data analytics is a part of data science, but some companies actually deal them slightly differently. Now, some large companies have a different, different job which does only analysis, different job which does only machine learning modeling. Uh, Now, yeah, Dilip, you have to ask Harizo for that. I'm not really, aware of what should be done here. We want the next session class. Yeah, beyond this, yeah, this was supposed to be the last session. About the other topics, I mean, this is basically, conclusion of the boot camp. If you want to like explore any other topic, you can like contact me personally. I'll share some good resource over that. But then you have to like put some effort over it. Now, this is more of a introductory boot camp. We introduced different topics to you, like we introduced topics from higher level. To get to into the depth of those topics, you have to like read books. Now, linear regression, I told you on a higher level, कि, okay, we optimize this error. Okay, we optimize this loss function. Now, where do we get this loss function? What are the assumptions we have of the data over the data? So the x variable which we took, we have some assumptions over it. The primary assumption is that every row inside this x table is supposed to be IID. So x is a set of IID random variables. What IID means is independent and identically distributed random variables. These are some details which are associated with linear regression. So first one is, when you get into company and do apply these methods there, you have to like get into these details there. You have a brief idea what linear regression is, but then like to get to do some rigorous work out of it, you have to get into details. And to get into details, now that you have some brief idea about what linear regression is, you can like check out its LinkedIn, check out its Wikipedia page, and check out some books as well to get the idea. Tableau or Power BI. I personally use Tableau, yeah, but Power BI is also like equally good. But then I haven't used them. I mean, utna that much. I haven't used them like a lot to be able to classify which is better, which is not better. But either ways, I think you guys are like college students, and with your college email ID, you should be able to get a free access to both these softwares. Tableau Desktop has a free access for students. Power BI as well has a free access for students. You can try them yourself and see which one is better. Can the algorithms in ML be used in deep learning? Well, ML and deep learning are slightly different. Machine learning revolves around some statistical methods to do the modeling. I mean, machine learning is a slightly more advanced way of statistical modeling. Deep learning is a slightly different way. Deep learning starts from neural networks. Excuse me. Yeah. Deep learning starts from neural networks, and it is not really statistical. It is, I mean, there is definitely some statistics involved in the backend, but then it is not very statistical. It is more of a search algorithm. So there are so the assumption in deep learning is that, like in machine learning, you had linear regression. You had parameters whose numbers were like kitne. Let us say you have eight columns in your feature matrix. So you have nine variables, nine parameters in. So you have nine parameters in linear regression. In deep learning, what the assumption is, ki, okay, instead of 9, what if I have like 900 parameters? When you have 900 parameters and you do some sort of search, you apply some sort of search algorithm over it, you will eventually, learn something out of it, and correspondingly, your model would be very accurate. So that is the logic behind deep learning. So the primary logic is you increase the complexities of the model by increasing the number of parameters. I mean, okay, it's actually the reverse. You increase the number of parameters by increasing the complexity of your model, and then by a very efficient search algorithm called gradient descent, and by efficient search algorithms, you basically search the most optimal values of all those parameters. So that is the idea behind deep learning, right? And so that is the idea behind deep learning. It is, it, the ideas are borrowed from machine learning, but they are being implemented at a much higher scale and complexities. Next question is, Tableau or Power BI, which is preferred? That again the same answer. How deep learning part of machine learning? So I just answered it. I hope it clarifies the question. Any additional question? So I think there are no more additional questions. So yeah, fine. I think you enjoyed it. Enjoyed this conversation. What is the actual work of data analytics? The ground reality of data in the industry. Well, I am not really that much into the industry. Right? I don't have a lot of exposure to industry, but data analytics is, reality of the data domain. So data analytics is more like, you have data and you derive insights out of it. Just the way we did, like in the case study where we were like handling some employee details and the job details, we found out some insights out of it. Okay, this employee is generating higher revenue, but we are giving more less salary to him or her, right? So the in that way, like so that is data analysis. Um, so this is like the sort of work which you will get if you get into data analytics industry. More of like consulting work. So I mean, you are consulting some manager by analyzing his or her data, right? So you have to consult. So in this case, you're consulting the manager. Ki, okay, this employee is doing more work. He or she is getting you more revenue. Please give him or her a higher raise, right? Or a bonus or a promotion, something like that. You can like use this. You can use this in various other ways as well. Like, okay, if you are, let us say, running some what? If you are running Netflix, let us say you are running Netflix, and in Netflix you see, okay, you store the age group of the individuals watching Netflix, and you also store how much viewing hours they have, like how much time they watch, and what is the age group. That can be a very interesting analysis. Like you will feel, okay, which age group primarily watches Netflix, and accordingly you can like you know accordingly you can have content according to that age. So let us say like age group 18 to 30 watches I mean, contributes the highest viewers to Netflix. We'll incorporate more content, for that, which suits that age group more. Right? Let us say we had like, okay, 60 plus people watch Netflix the most. So we'll incorporate like contents which are more suitable to the 60 plus age group. Like let us say we'll have some uh, you know, movies which have higher depth, or series which are slightly slow moving, or will contain some old movies. I mean, this is my personal opinion, but you might have contradictory opinions to it. Yeah. So, any other doubts? अरे यार अब इतना सारा job location affects the job salary. Yes, it might. अरे sometimes it doesn't affect. In some companies it doesn't. In some companies it does. I mean you have to take the decision. Like अगर किसी कंपनी में मतलब अगर कंपनी है सेम सैलरी दे रही है दो अलग अलग लोकेशन में दे रही है तो सस्ता लोकेशन में दो ना. Like Mumbai is a very costly location. Hyderabad is relatively cheaper. Gurgaon is cheaper. Bangalore is cheaper. So ये तो let's stick to the domain. Let's stick to our content. ये जॉब लोकेशन का तो यार अब इतना ज़्यादा नहीं बता पाऊंगा. I'm a fresh graduate. I mean, actually, I'm a fresh graduate. I'm a fresh graduate from IT Bombay. So, think there are no more questions. There are. कर लो यार. Time in the session end. Guys, the session is already like ended. I mean, if you have questions, you stay or like feel free to leave. Yeah, linear algebra, you need stuff like you need to know calculus for learning data science. You need to have mastery over calculus. You have to have mastery over linear algebra. You have to have calculus over stochastic. I mean, you have to have mastery over stochastic calculus. I mean, stochastic differential equation. And yeah, I think that should. Yeah, it's a of course differential equation optimization. And that should like more of do the Horizo se internship. Yeah, yeah. Thank you, folks. I think it's pretty. We are way past. We are half an hour past the allotted time, but nevertheless, it's a good discussion. So yeah, let's conclude this session here. If you have any more doubts, ask over the WhatsApp group. I'm there in the WhatsApp group as well. If you या probability वगैरह कर probability stochastic calculus करना है तो probability भी आना चाहिए. So anyways, like okay, let's conclude this session here. If you have more doubts, you ask me over the WhatsApp group. I think you have my number as well. But anyways, like yeah, fine. This concludes the session. Like yeah, I hope you enjoyed the session. I hope you enjoyed the boot camp. I hope it was a good learning experience. Thank you for being there. I hope you have marked the attendance. Like, and if you are like interested in the internship with Chorizo, please do take it. I mean, please do apply for it. And yeah, I think yeah. Thank you guys. Good night. Hope enjoy. Bye.